Okay, so now we're dealing with section 6.7, excuse me, and we're looking at how do we graph tangent and on cotangent. So we're looking at other trig functions, and now we're going to talk about tangent and cotangent. So first we have to talk about, wait a minute, where is tangent undefined? So what happens is tangent is y over x. So y over x here would start at 0 as we're going around in our unit circle. And here, we're going to be at 1 over square root of 3. So it's kind of a smaller number. Then it actually gets to here, 1. Okay? Then it actually comes over here, and it's square root of 3 over 1, which is even higher than 1. So as we're kind of keep going around the circle, it goes higher than 1. But then what happens here is it becomes undefined. All right? So here, it's no longer here. It's undefined. It doesn't exist. 1 divided by 0 is what we have here. That's my undefined. It really doesn't look that way. 1 divided by 0 is what we have here. Okay? Then it goes negative. Okay? So we actually start at 1 divided by square root of 3. You start at 0 and you kind of get higher, higher, higher up until a point where it's no longer, it just kind of doesn't ever cross. All right? Here at square root of 3 over 2 divided by a negative 1/2. It's just going to be, again, square root of 3, but this time it's negative square root of 3. So it's actually kind of higher, all right? Or actually lower, real low number. And then it gets a little less than low, so it goes to negative 1. And then this goes to negative 1 over square root of 3, which is smaller than negative 1. And then we go back to 0, okay? And then what happens is it starts again. 1 over square root of 3, 1 is a positive, and then we go back, and it's actually 1 over square root of 3, and it goes back to undefined, UND here. And then we go back to the negative. So it's actually like these two cycles are actually repeated, and we're going to be talking about that. Here it's negative 1, or excuse me, negative square root of 3. Then it's negative 1, then it's negative 1 over square root of 3. So it's like as you're going around this circle, I'm sorry, and this is kind of in the way here. Bring that down. I gotta get some extra space here. Sorry, guys. And I froze it out. All right. All right. So, as we're going around this circle, it kind of cycles twice. And that's important. That's unique to tangent and cotangent. So what I was describing, we start here at 0 and it starts here at 0. What happens is you go positive, it goes positive and it keeps going higher, but then it kind of, there's a point where it's undefined. And if you remember, undefined is an asymptote in our stuff. So it's where it can never cross. So that asymptote is here at 90 degrees, or also in radians known as pi over 2, okay? Also known as 90 degrees. Then what happens here is it starts off really low, and then it kind of does this again. All right, it comes back to a 0 here. It comes back to 0 at 80 degrees or at pi, and then it kind of goes back up, and it has another cycle where we have this, where this undefined part starts again here at 3 pi over 2, which is 270 degrees. And then it cycles again like the same, the whole cycle will get repeated. So on a technicality, here, and this kind of actually would happen this. So you can kind of see this graph, it looks a little different. It's not our up and down sine wave. It's not like the same wave for tangent. It is this curve that has an upper and a lower, no upper and lower limit, but it kind of curves to the left and to the right. And so when we want to show one cycle for tangent, we actually start usually at 0, and we actually end here at pi. So one cycle, one period, the traditional period, actually happens in just pi radians, half of a circle, all right? If it was degrees, it would be 180 degrees. So this is technically the pi shown in one cycle here. So the big thing that's different here is that the period is in half of the time. You'll get a complete cycle, a complete period in pi degrees in half of the circle, where in cosine, sine, secant, cosecant, it happens in the full circle in 360 degrees. Now let's do the same thing, and we'll talk about cotangent. And what actually happens with cotangent, and where that's undefined, is it starts off at 0 degrees, undefined. I'm going to kind of extend here. So if we had our circle, all right, it starts off at 0 degrees, undefined, okay? And then what happens is it starts off really high here. So it's going to start off at square root of 3 over 2 divided by 2 would be square root of 3. All right, so it starts off here at square root of 3, which is a high number, and then it goes to 1, all right, and then it goes to, or actually low. Okay, so what we're going to look at here now is that we were looking at the cotangent, and as it goes around, it goes to this 1, and it's going to come here to 0, and then it's going to come here to a -1, and then it becomes undefined again here. Then we start another cycle where we're at +1 here, we go back to 0, we go back to -1, we come back to undefined, and we do kind of have these, this is square root of 3 over 1, it goes higher, and then this is lower, 1 over square root of 3. It goes lower to begin with, -1 over square root of 3. All right, so what happens? What happens? What does that look like? Let's look here at what this looks like. I'm going to bring these down. So we're going to be graphing this here. I'm going to get rid of some stuff here, sorry. All right, so we're graphing cotangent. So kind of compare it to tangent. So what happens is at 0, it's undefined. We have that undefined value here. Then what happens is it's really actually a very high value, and it kind of comes down, and it becomes 0 here at 90 degrees, which is pi over 2. At 180 degrees, it becomes undefined again. All right, so what happens is it starts high, and it comes in here as at 0, and then it becomes lower here. Okay? So I want to show you on the same graph here. Tangent I'm going to do in red. If you remember what tangent actually looked like, and it's kind of hard to see here, but there's my tangent. Tangent actually looks like this. All right, and cotangent, and this is at the 1, at the point at 1 here. And cotangent actually is kind of the flip of it. It kind of flips over, but some things that are different. Tangent is undefined at pi over 2 and negative pi over 2. And cotangent is undefined at 0 and at pi. All right, so there's a little difference. Let me see if we go through some examples here. And then we do have to deal with amplitude and period and phase shift and things like that. So let's first just start with what would we do if it was just, let's just go and say, how do we graph this? Tangent of x, okay? So tangent of x, what we need to know is that it has a period of, usually it's pi, okay? So usually our tangent of x starts here, or starts at 0, and then kind of goes up like this, and it has an asymptote here. It's undefined at 90 degrees, which is pi over 2. It's undefined. And a lot of times we do this, and we say it's just easier to show here it's between pi over 2 and negative pi over 2, because it's easier to show the whole curve. Sometimes we'll show it over here that it kind of comes down here again like this. We'll show 2 cycles, all right? But between my 2 dashed lines here is just 1 cycle. It's the blue and the green line, okay? Now, if we want to say in the usual time we have 1, we're going to have 3, okay? Let's talk about amplitude first of all. Amplitude is 2. Well, you know what? Amplitude, being 2, there is no highest or lowest point, because technicality, it kind of goes on forever. So it's kind of like we have what's called, I like to call it my fake amplitude. So our fake amplitude is 2, but we pretty much ignore it. All right? We can ignore that altogether. There really isn't an amplitude when you're talking about tangent and cotangent. The period, instead of the period being 2 pi divided by my k, since it cycles in just pi and half of a regular period, it's pi divided by k. So pi divided by 3. So here, instead of saying, you know, this usual 1 here goes in this 2 pi, you're going to have 3 cycles in the same thing. So what happens is this one actually kind of goes like this, 1, and then we can do 2, here's another one, and 3, where there's usually just the 1 cycle. Okay, so that would be my 3 cycles in 1. It kind of goes in the usual space where we have 1 cycle. So I don't know, I could probably spread that out a little bit, but we have 3 cycles in one. So usually what we do, or how we show it, I'm going to kind of go through this again, is we say, okay, we have tangent. We know tangent goes like this, and we show it like this. And then we just show that instead of having this asymptote here at pi over 2, all right, and at negative pi over 2, so it has a pi between here, the distance between these points should be pi over 3, okay? So this, on a technicality, is going to be pi over 6, sorry, and this is going to be pi over 6, not pi over 2, or negative pi over 6. So that the distance between these two is pi over 3. So what I did in my head is I said, okay, usually when it's pi, when the distance here was pi, it was half of it, pi over 2 was here, negative pi over 2 was this way. Now what I did is I took pi over 3, my period, and I divided it by 2. All right, so pi over 3, sorry, pi over 3, I can multiply it by 1/2. That's where I got the pi over 6. So I can say this is my positive pi over 6, and this one here was my negative pi over 6. Let's do another example, and hopefully as more examples it'll become a little bit more clear. I know it's not going to be crystal clear right now. So what my expectation is, go ahead and write down your fake amplitude. I mean, it's okay to know that, hey, I know that's what the amplitude would be if I did have a cosecant, but it's really kind of a fake amplitude. We're not going to deal with that yet. I'm going to check something out. Nope, I was right. Okay. So we're going to write it down. It really doesn't mean anything when we draw it. The period. If you remember for the period, what we do is we take pi instead of 2 pi divided by my k, divided by 1/3. That would be the same thing as pi over 1 times 3 over 1. So my period is 3 pi. So my period here is 3 pi, and we'll deal with that here in a minute. And my phase shift is the left or the right. There is no phase shift, so we can put none here. But there is a vertical shift of 2. What that means is, in a cosecant, this is how cosecant goes usually, and it crosses right here. What that means is, instead of crossing there, 1, 2, we're going to have it cross a little higher. So technicality, what we want to do is bring this up here to 2. So you could do it like that, and you could show a dashed line and say, okay, this is my 2. Okay, and that's my shift. You could also have left it down here, and I see a lot of students doing this, and they just indicate that, hey, this is a 2 here. It wasn't a 0. So we just assume it's a 0 if nothing's written there. Otherwise, we have 2. I don't really care for this one since I have my dash line there. I'll go ahead and put this as a 2 up here, and then this is 0, and show that I'm actually shifting this above. Now let's talk about our asymptotes. In a cosecant, or cotangent, I apologize, our asymptotes are usually at 0 and at pi. So this is our period. All right, well now our period is 3 pi. So really it's not between 0 and pi, it's between 0 and 3 pi. And that's all I need to do is I need to indicate that that is 3 pi. So it's not like I have to do as much kind of calculation as I did with the tangent. So indicating this is 3 pi and this is 0, I'm showing one rotation here and I'd be done. If I wanted to show a second rotation, I could do that with just doing this, kind of doing my arrows again, and saying, okay, if I wanted to show 2 cycles, 2 rotations, this would be 6 pi. All right, so again, my period would be a distance here of 3 pi. So I had to just go 3 pi plus 3 pi. Sometimes we'll say do it over 2 cycles. Sometimes we'll just do it over 1. I think I have time for one. So here I want to do problem number 9, and I'm going to rewrite problem number 9, and I'm going to rewrite it as y equals -4, or excuse me, I'm not going to have that -4 till the end. I'm going to write the cotangent of 2x minus pi over 4, and then I'm going to have the -4. Okay, so I don't have enough space there. I'm going to do it here. Okay, so my amplitude there is no amplitude. Again, it's a fake amplitude anyway, so or we could just call it a 1. 1 is my fake amplitude. My period is pi over 2. So you're going to take pi divided by our k. Our k is 2 here. So our period is pi over 2. Our phase shift is going to be a positive pi over 4. So remember, whatever makes this a 0 in the parentheses, and that would be a positive pi over 4. Our vertical shift is a -4. Couple ways you could do this. You could have a new midline. here at a -4. All right, you could have also called this, let's do it this way, let's call that